So we did some rate law calculations using the method of initial rates. So for those of you who are taking this online or watching this video online, what I recommend is either downloading these problems from the course website, try it on your own, and then watch the video when you're ready to see the answers. Or you could hit pause, try this on your own, and then when you're ready to see the answer, you could hit resume. So here are the three that's a typo. What's the rate law for the reaction below? Okay, and then here are the data that you have to be given to use the method of initial rates. So pause the recording, try it, and then hit resume when you're ready. Here's number 2. What's the rate law and value of K, including units for this reaction? Again, hit pause, try it for yourself, and then resume when you are ready. And here's problem number 3. Rate law and value of K with units for this reaction. Again, hit pause, try it for yourself, and then when you're ready, you can resume. All righty, so we're going to go through each of these. Now, I have worked these out myself. You follow along with me, check my arithmetic. I will make a PDF of my answers, and I will post that online as well, so that you have both the video and the PDF to refer to. All right, so for trial 1, for problem number 1, we need to write ourselves a generic rate law first, right? Here's the generic rate law. Rate equals K times iodide to some value X. Who remembers what OCl minus is? It's the same thing as ClO minus. OCl and ClO are the same thing. They are hypochlorite, right? So we want to solve for X and Y in order to have a specific rate law, right? So to find X, let's do X first. We want to pick a pair where iodide stays constant and, where iodide is changing and hypochlorite is staying constant, right? Because we want one of them to cancel out. We can't have one equation with 2 unknowns. That would be impossible for us to solve. So what trials did you pick? Anyone want to share? 1 and 2? That's what I picked too. Trial 1 and trial 2, right? Because iodide is changing, hypochlorite is not. Okay? So I chose 1 and 2. And you could have done 1 over 2 or 2 over 1. It doesn't matter, right? Because if you do it as 1 over 2, that'll be 2. If you do it as 2 over 1, that'll be 0.5. So it's just up to you. Do you like to have a big number? Do you like to have a smaller number? So I like to use big numbers for going over this stuff in class, just because I think it makes it a little bit easier seeing what you're doing. So we're plugging in the rate. So rate is 7.91 times 10 to the negative 2. And number 2, 3.95 times 10 to the negative 2. Rate equals K. Now we're just plugging in our value. 0.120 to the X. 0.180 to the Y, divided by K times 0.060 to the X, 0.180 to the Y. Now we do some reduction, right? K over K cancels. This quantity cancels. This divided by this gives me 2. This divided by this gives me 2 to the X, right? So 2 equals 2 to the X. Therefore, X must be what? What is X? 1, right? Anything to the first is itself. So here's our specific rate law. Let's work it out as we go. What is the order with respect to iodide? If X equals 1, do I need to write this 1 right here? You can, but it's not necessary, right? If it's a superscript of 1, that means it's first order with respect to iodide, right? Everybody with me on how we solve for X? All right, now let's solve for Y. So what'd you pick to solve for Y? Anyone want to share? 2 and 3? That's what I did too. 2 and 3. All right, solve for Y. Again, you can do it as 3/2 or 2/3. It doesn't make a difference. I did it as 2/3. So experiment 2 over experiment 3. Okay, so the rate, plugging it in, rate is equal to 3.95 times 10 to the negative second. Rate equals K times 0.060 to the X, 0.180 to the Y. Dividing that by trial 3, rate equals 9.88 times 10 to the negative 3. K, 0.060 to the X, 0.090 to the Y. Now we just do our simplification. Right? That cancels, that cancels. This over this gives me 4. And this over this gives me 2 to the X. What must, oops, not X, Y. So what is Y? 2, right. So rate is equal to K times iodide times hypochlorite. So it's second order with respect to hypochlorite. It's first order with respect to iodide. What's the overall order of the reaction? Overall, the order is 3, right? Because I add the 2 superscripts to get the overall order of the reaction. That's not something that I asked you for on here, but I could ask you for on the test. Is everybody cool on how we got the value for Y? Oh, no, I need my initials there as well. Okay, now we solve for K. And to solve for K, you pick any one trial you want, doesn't matter which one, and just plug it into your specific rate law. So this is our answer for the rate law. So we just plug into there. So I picked experiment 1. I was lazy, didn't want to look at too long. Now we have to include units, right? That's what gets a lot of people in trouble. So we need to watch our units carefully here. So rate 7.91 times 10 to the negative 2 moles per liter second is equal to K times 0.120 moles per liter times 0.180 moles per liter squared. All right, we just plug everything into the rate law that we just determined. Do we agree? Yes. Now we just do some algebra, right? So this just comes straight down. 7.91 times 10 to the negative second moles per liter second is equal to K. Okay, 0.18 squared times 0.12. I got 0.00389. That is 0.18 squared times 0.12. That's what I got here. Now, in terms of my units, when I square moles per liter times moles per liter, what does that give me? Moles squared per liter squared, right? Moles per liter squared gives me moles squared per liter squared. And then if I take that and multiply by moles per liter again, what does that give me in terms of my units? When I multiply, what do I do to the exponents? Add, right? So that would be moles cubed per liter cubed. Does everyone see why the units here are moles cubed per liter cubed? Does everyone see why the units are the way they are? Yes? So how do I get K by itself? Just divide both sides by this quantity. That's a O. Divide both sides by 0.00389 moles cubed per liter cubed. All right, so that goes away. Leaves me with K. So to get the math, 7.91 times 10 to the negative 2 divided by 0.00389, that's easy, right? That's easy. So that gives me, rounding to 2 sig figs, that gives me 20 as my number. But let's figure out what my units are. Let's work off to the side here. If we've got moles per liter second divided by moles cubed per liter cubed, that's the same thing. Dividing fractions is the same thing as what? Multiplying by the reciprocal, right? So that's moles per liter second times liter cubed per mole cubed, right? So mole goes away, that exponent becomes 2. Liter goes away, that exponent becomes 2. So what does that leave me as my units? That gives me 20 liters squared per mole squared seconds. Like I said, the units of K are going to be completely the result of whatever your rate law ends up being. Because if I'm squaring or cubing or whatever, that's going to affect my units. Right? If it's all first order versus if it's 1 first order and 1 second order, 1 first and 1 third or 2 seconds, right? That's all going to make a difference in what K ends up being. Do you need to base it off of the overall order? You base it off of the rate law. So this was squared, that's why it was moles per liter squared.
But you said when you added the overall.
To get the overall order, you add them together, yes. So the overall order would be third. The order with respect to I minus would be first, right? And the order with respect to hypochlorite would be second. Does that make sense?
So then why would you use the...
But I use this one to get K's units. Yes. Any other questions on number 1? How are we feeling on this one? All right. Let's move on to number 2. Number 2 is asking us to do the exact same thing. We've just got more information this time. Okay, so I don't want to lose that. That's number 1. I'm going to scan it and post it online for you to look at that way. All right, so here we've got 3 reactants we're dealing with, right? So let's first write a generic reaction using A, B, and C, or X, Y, and Z, or whatever variables you want to use. Here's our generic rate law. So rate is equal to K times the concentration of bromate. I'm just going to use X, Y, Z, bromide, Y, and H plus, which typically we won't write like that in this class. We write it as hydronium, but that's okay. So now we got to solve for X, for Y, and for Z. We've got to solve 3 things this time. But we can do it. We can do it. We can make it through. Okay, so let's solve for X. Anyone want to tell me which trials you picked to solve for X? 2 and 1, that's what I picked. 2 and 1. You can write it as 1 over 2 or 2 over 1, makes no difference. I wrote it as 2 over 1. Experiment 2 over experiment 1. So rate is equal to 1.6 times 10 to the negative third, and 8.0 times 10 to the negative fourth is equal to K. Now I'm just plugging in 0.10 to the X, 0.20 to the X, 0.10 to the Y, and 0.10 to the Z, divided by K times 0.10 to the X, 0.10 to the Y, 0.10 to the Z. Now we do our division. The K's cancel, and the 2 other quantities cancel. So when I do my division, I get 2 equals 2 to the X. If you'd done it the other way around, you'd get 0.5 equals 0.5 to the X. You're still going to get the same value for X. So X is what? 1, right? What to the x gives me itself. Well, x must be 1. So let's write our specific. Let's start filling that information in. So rate equals k. If the x is 1, do I need to write it? You can, but you don't have to. All right, so that's 1 down. We got 2 more to go. So everyone with me on how we got x? Everybody cool on solving for x? Yes? All right, let's solve for y now. What did you pick to solve for y? 2 and 3? That's what I did. And you can do it as 2 over 3 or 3 over 2. Same difference, you're going to get the same answer either way. So solve for y. I wrote it as 3 over 2. I just think it's easier to see when you have a whole number or number greater than 1. So experiment 3's rate is 3.2 times 10 to the negative third. Rate equals k times 0.20 to the x, 0.20 to the y, 0.10 to the z, divided by, rate for trial 2 is 1.6 times 10 to the negative third. K for trial 2, let me plug in 0.20 to the x, 0.10 to the y, and 0.10 to the z. We divide, k's will go away, these other 2 quantities go away. We get 2 is equal to 2 to the y, so just like the previous one, y is 1. So it's first order with respect to bromide. Right, and if the value is 1, you can write it if you want to have something there, because you worked so hard to get it. But if you don't want to write it, that's fine too. Any questions on how we solve for y? Okay. Now let's solve for z. So in z, what did you use? I did too. All right, so solve for z. I did it as 4 over 1. So experiment 4 over experiment 1. So rate is equal to 3.2 times 10 to the negative third. Rate equals k, 0.10 to the x, 0.10 to the y, 0.20 to the z, divided by, rate for trial 1, 8 times 10 to the negative fourth. And then we've got k, 0.10 to the x, 0.10 to the y, 0.10 to the z. We do our division, cancel, cancel, cancel. We get 4 is equal to 2 to the z, right? So what must z be? Z is equal to 2, right? So it's second order with respect to hydronium. So there's my rate law. When I ask you what's the rate law, that would be your answer, right? You don't write this as your answer because this is the generic rate law. That's not going to be your actual answer. This is the answer that you would put on the test, right? That would be your answer. Now we have to solve for k. And to solve for k, we can plug our values from the data table into any one, from any one of those trials into our rate law. I just picked trial 1, Steve's first. So let's solve for k. So if rate equals k, BrO3 minus Br minus H plus squared, plug in everything in. We're watching our units, right? Because I did ask for units. So here we go. 8.0 times 10 to the negative fourth moles per liter second is equal to K times 0.10 moles per liter times 0.10 moles per liter times 0.10 moles per liter, quantity squared. Right, because this is superscripted 2 right here. So nothing happens here, that's just brought down directly. Moles per liter second is equal to K. All right, 0.1 squared times 0.1 times 0.1, that gives me 1 times 10 to the negative 4th, right? If you take 0.1 and square it, and then multiply it by 0.1, and then multiply it by 0.1, you'll get 1 times 10 to the negative 4th. What are my units going to be, though? Moles per liter, let's start at the end. Moles per liter squared gives me moles squared per liter squared, right? Now I'm going to multiply that by moles per liter. All right, so that gives me mole cubed per liter cubed. And now I'm going to multiply that by moles per liter. So that gives me what? Moles to the 4th, liters to the 4th. Do we agree on how that we got those units? So 1 times 10 to the 4th, moles to the 4th, liters to the 4th. So how do I get K by itself? I divide both sides by this quantity. 1.0 times 10 to the negative 4th, moles to the 4th, liters to the 4th, that goes away. 1.0 times 10 to the negative 4th, moles to the 4th, liters to the 4th, and that is there. So 8 times 10 to the negative 4th divided by 1 times 10 to the negative 4th, that's just 8, right? So that part's easy. But my units are the funky part. Let's figure out what they are. I'm staying right here because if I want the camera to capture it, I need to stay in this box. So if you wonder why am I not writing on the rest of the board, well, I have to stay in this little tiny window if I want the camera to capture it. All right, so moles per liter second divided by moles to the 4th, liters to the 4th is the same thing as moles per liter second times the reciprocal, right? Liters to the 4th, moles to the 4th. So what happens when I multiply these things? That goes away and that becomes a 3. That goes away and that becomes a 3. So that gives me liters cubed per mole cubed second as my units. Nope, and that equals K. Do we agree on number 2? So if I said, what's the order with respect to bromate? It'd be 1. What's the order with respect to bromide? It'd be 1. What's the order with respect to hydronium? It'd be 2. But what's the overall order of the reaction? How do you get the overall order? Add them all up, so it'd be 4. Right. Questions on number 2? If you make it through number 2, number 3 is kind of like a day at the beach, right? Because there's only 2 to deal with in number 3 as opposed to 3. Is everyone okay if I erase this? Does anyone need me to leave up the K calculation any longer? Am I going through it too fast? It's always hard to gauge. That's why I try to write things myself, because I'm assuming that hopefully the time it takes me to write it and then talk about it, that's giving you enough time to write. But that's the beauty of the video. You can always go back and rewatch it. Or come see me in office hours or send me an email. All right, let's look at number 3. Rate law and units of K with units for this reaction. Just because we have 5 trials, that doesn't make our work anymore, right? It just means we've got 5 trials to pick from. So don't let the fact that it's 5 trials mess with you, okay? Because what you're interested in is the number of reactants, not how many trials you have. So if you've got a whole bunch of trials, that just means you've got more options to pick from. All right, first thing we need to do is we need to figure out our generic rate law. Here's the generic Let's see, rate is equal to K times the initial concentration of iodide to some quantity times the initial concentration of peroxydisulfate to some quantity. Right? That's the generic rate law. If you wrote this as your answer on the test, would you get it right? No, that's just the generic, right? We want to know the actual values of X and Y. That's your answer. Okay? I've had students do this before. They'll say, this is the rate law, and that's not. This is just the space. This is just like our placeholder. Right? We have to actually solve for X and Y to be our final answer. So let's solve for X. I picked 2 and 1. I picked 2 and 1. If you picked a different pair, that's fine. You'll get the same answer either way. So I did 2 over 1. So experiment 2 over experiment 1. So 6.25 times 10 to the negative 6th over 12.5 times 10 to the negative 6 is equal to K. For trial 2, 0.040 to the X, 0.040 to the Y. Okay, now we're doing it this way with a larger number on bottom. This is a brand new marker and it's already halfway gone. All right, this over this gives me 0.5. This over this gives me 0.5 to the X. So X equals 1. So our specific rate law, which will be my final answer eventually, rate is equal to K, initial concentration of iodide. So first, do we agree on X? Do we agree on X? Any questions on how you get X? Okay, now let's go through it again for Y. For Y, I picked 1 and 3. That's what I chose. All right, so let's see. I did it as 1 over 3. Experiment 1 over experiment 3. And this is for Y. Okay, so let's see. 12.5 times 10 to the negative 6. Rate equals K times 0.080 to the X, 0.040 to the Y. Dividing that by trial 3, the rate at trial 3 is 6.25 times 10 to the negative 6. K, 0.080 to the X, 0.020 to the Y. K's cancel, X quantities cancel, so that gives me 2 is equal to 2 to the Y, therefore Y equals 1. Okay, so it's first order with respect to both reactants, second order overall. S2O8 2 minus first order overall, second order overall, excuse me. So there's the rate law. If I asked you for the rate law, that's what you would put. You can put the little ones there if you want, but you're not required to. Are we good on solving for Y? Yes, good on solving for Y. Any questions for erase Y? Okay, now let's solve for K. The units of K are going to be significantly less nasty than they were in the previous one because I'm not squaring anything, so that's nice. This time I picked trial 2, just for fun. So, solve for K. I used trial 2 this time. So 6.25 times 10 to the negative 6 moles per liter minute, right? My previous ones were moles per liter second. This one's in moles per liter minute. Got to look at those units here up in K, right? Is equal to K times 0.040 moles per liter times 0.040 moles per liter. Right? I'm just plugging everything into my rate law that I just determined. So this comes straight down, 6.25 times 10 to the negative 6 moles per liter minute. Oops. Moles per liter minute is equal to K. Now 0.04 times 0.04, that's easy arithmetic, right? That's just 0.0016. What are my units going to be? Moles per liter times moles per liter gives me moles squared per liter squared, right? Moles squared per liter squared. So K, therefore, divide both sides by that quantity. 6.25 times 10 to the negative 6 moles per liter minute divided by 0.0016 moles squared per liter squared. Right? This divided by this numerically gives me 3.9, because I've got two sig figs to deal with. 3.9 times 10 to the negative third. That's what that times that gives me. To get my units, let's go off to the side. Moles per liter minute divided by moles squared per liter squared. It's the same thing as saying moles per liter minute times liter squared per mole squared, right? Flip it. This one goes away and that exponent becomes 1. This one goes away and that exponent becomes 1. We don't need to write an exponent of 1. We can, but we don't have to. So my units are going to be liters per mole minute. So there's my rate law and there's my value of K. How do we feel about number 3? How do we feel about method of initial rates in general? Generally speaking, feeling all right about it? Yes? All right, great. So I will scan these answers and I will post them on the website as a PDF. So if you want to look at it again without watching the video, you have that option. Otherwise, I'll see you tomorrow for lab. Don't forget you have a pre-lab due. And have a good day.